to be focusing on today, and the one I'm personally most passionate about, is the system design interview. So when we say system design, a lot of people think we mean architecture. We're going to put up a nice flow chart with database here, load balance here, and that's enough. There's actually a lot that goes into system design. And today we're going to walk through a lot of these key concepts. Alongside that, we're also going to go through the sponsors, which make a great conference like this possible. So thank you very much for the sponsor today, who helped make all of this possible. Bit of a disclaimer, I haven't worked at Google myself. What I'm going to be going through today is based off my time and my experience going through a lot of these concepts with Google Tech leads, and my own experience as an interviewer. This is the first time I've done a DDD talk, so I'm sure there's going to be mistakes. Please bear with me. So, today, there's going to be kind of three parts of this story. The first thing we're going to go through is what an interview is like. I assume some of you would have done at least one interview. It's going to be going through kind of the common pitfalls people make in system design interviews. We're then going to kind of distill that down to, I think, the key point of the talk, which is the big reason people kind of fall down, not just at these interviews, but actually day to day when you're designing your own systems. From there, we're going to move into a walkthrough of how to really approach system design in a structured way. I want to stress, this isn't just going to help you with interviews, it really is going to help you in your day-to-day system design. And I think if you're really paying attention, it's going to help mold how you approach problem solving as well. So for our interview today, we've got our main characters. We've got our interviewer, our system design interviewer from Tech Company X, and us, the hopeful interviewee. So it's interview day. You're a bit nervous. You're going to skip breakfast. You're going to crack open your laptop early in the morning, and you're going to check when your interview is. It's in about 15 minutes. You're going to want to join early, don't want to be late, kind of make sure you don't have any issues joining Meet or Zoom or whatever. The interviewer signs on, right on time, and introduces herself. She asks you to introduce yourself as well, and you kind of chit-chat back and forth a little bit. Eventually, she asks, "Are you ready for the actual interview?" You say yes. She's then going to give you a prompt. What's the problem we're trying to solve? I want you to design a social media application where users can share messages with their friends. So think something like Twitter. Luckily, you're prepared for all this. You've done systems design in your day-to-day. You've done architecture. So you end up with something like this. It's pretty standard looking. I assume most of you will have seen something similar to this. Nothing wrong with this kind of stack. You've got a high availability setup here, you've got a database, and your static assets are behind a CDN. Lots of best practice here. No big issues, I think. Can we handle more traffic? Absolutely. Sprinkle a bit of caching onto it. Sprinkle caching everywhere. For those of you who haven't used Redis before, it's an in-memory database that's usually used as a cache. So that sounds good, more performance. And I have seen all of these configurations in my time as an interviewer. We're going to add Redis to absolutely everything. And I'm going to talk a lot about trade-offs today. But good thing is everything's cached, everything's going to be way faster. One of the trade-offs we make for this performance is this is impossible. You can't do this. The only way you can connect Redis up here is to the service, where it says compute. Sadly, that's the least common way I've seen Redis attached. So, your interviewer is going to call this out. That's really interesting, but I don't think that's quite possible. What other options do we have? What else do we see quite commonly when we're doing these interviews? We'll throw Kubernetes at it. I'm not entirely sure how that helps in any way. We're also going to go cockroach at it because it's new and because their marketing team have done a fantastic job. It's like Postgres, but better in every way. And I stress today we're really going to talk a lot about different approaches, what the trade-offs are, and far, far less about the technology. One really common pitfall is just reading the front page of these technologies. Dynamo is another one that comes up, Yugabyte, Kafka, whatever. They're going to pitch to you all these great benefits, and they're going to say, it's so flexible, it's useful in all of these cases. You're really going to have to dig for some of those trade-offs. If you don't understand this well, if you don't understand what you're trying to solve, you're going to end up in a bit of hot water. You're going to end up with a delayed or incomplete solution. We haven't really gone through the requirements, so who knows what we're really building. If we're going to have a lot of back and forth with product after we've already done a lot of upfront design, there's going to be delays. There's going to be, oh, but I thought we were going to build it this way, not that way. If you don't talk to product at all, they're going to think you're building one thing, and you're going to have built another thing. Your solution is going to be incomplete. It's also going to be expensive. You haven't really done much to look at where your data is going, look at what compute you're going to need. So you're going to end up throwing a lot of hardware at it, which is going to come at a lot of cost. It's also going to be unreliable. We've put up design up there, but how much throughput are we actually trying to handle? How much load does our system need to be able to support? And of course, it's going to be buggy as well, especially if you're going to go with those hot new databases with a lot of eventual consistency. But we're going to go through that later. So your interviewer is very nice, very professional, very polite. She's going to let you down gently and just say, I don't have any more questions. Why should she? We haven't really demonstrated our ability to explain our decisions, so she's going to save everyone time. As I mentioned at the start, we've made a few different mistakes here, but I'm going to take a shot at distilling it down into one really, what I think is a common cause. And giving it away a bit early, but I really think the mistake is unintentional design. What I mean by that is we can get very caught up in applying best practice, the newest technology, the one with the most purported benefits. The problem with that is when we're asked to explain these decisions, why did we pick this and not something else, we might not be able to explain that. And that's kind of what I mean by unintentional. If it was an intentional design, we'd much better be able to say, yes, this is why we chose it. What we've actually done is really sidestepped thinking about the problem and just gone for a lot of shortcut heuristics, right? Which I think best practices can be sometimes. So let's try this whole process again, but this time we'll do it with a bit more intention. So let's wind back the clock. What is system design? And I just copied this straight from Wikipedia. It's defining the architecture. Well, we've got a diagram, so I guess we have an architecture. We have product design. Actually, no, we don't have product design. Modules, interfaces, data. We ain't got that. We haven't really talked about it. We don't have requirements to start with. Now, the product design part is easy. We're just going to blame product. We'll just stonewall them off, deliver our solution, and then fall over. What we actually want to do is really collaborate with product, or your interviewer, or just your team in general. I think this works both ways. Product may simply throw requirements over the wall and not really want questions, so you can do this one in reverse as well. You deliver a solution and blame engineering. If your company's particularly low on funds, you can blame each other as much as you want while you're packing all your things into your boxes because we failed to launch. So, onto the walkthrough. How are we going to get ourselves out of this mess where we've thrown together a really unintentional design? The first place to start is functional requirements. What are we actually trying to build? When we have a discussion with product, what are we going to talk about? We want to have a common understanding of what we're trying to build. So, winding back the clock, we want to design a social media application where users can share messages with their friends. So, what are the key features? What things do we need to provide so that customers can do that? The first thing, users do need to be able to post messages. That's an important one. We also want to make sure that people can share these messages with their friends. How they're going to do that is by following each other. And we also want to make sure that you've got a nice feed of what all your friends are saying. I think we can focus on these three. What I want to stress is that you don't have to design every part of your application here. You want to spend most of your time, most of your effort, looking at areas or features where either your product has a lot of risk around it, a lot of risk around that feature, or where you're really going to extract a lot of competitive advantage. And I think if we get these things right, at the very least, we do actually have a social media platform. So what about those things we left by the side? Let's say authentication, for example. We can talk through that. So for authentication, there's a lot of nice patterns for doing this. I want to say it's a largely solved problem. I'm going to tell my interviewer that. They're going to be okay with it, and we're going to move on. If they're not okay with it, of course, you're going to have a bit of a chat about it. So we've made some progress here. Just by refining the functional requirements, we at least know what we're going to build, what our product is going to look like. There's less risk of your solution being delayed or incomplete. You still have all these other problems, though. How are we going to deliver these use cases to our users? So we're going to move on to non-functional requirements, the things that aren't features, but we really need to think through. And I think this is where it gets really interesting. Actually, I'll expand a bit more on that. To be clear, these are going to be things that our application needs to support. It just isn't a feature. Users aren't going to be too aware of it, and you're not going to put it up on your website. So, throughput. How much traffic does your site need to handle? There's two major ways this gets split up. Read throughput, so reading against your data stores, reading against your services, is usually pretty easy to scale, and scale horizontally too. Write throughput is a lot tougher and comes with a lot of trade-offs, which we're going to discuss later. So do we need to go away for a few weeks and talk to our data team and really get an exact picture of how much traffic we are handling, how many users we have, or if we haven't launched it, how many users we're going to have? Not really. We can be pretty rough about it. We just want to get a rough picture of, is it a lot of throughput? Is it a little bit of throughput? So we can start with some napkin math. A pretty standard prompt for this, we can just ask, hey, how many users are we expecting to have? We're going to get back a number, and this is something you can collaborate product, or if it's an interviewer, they'll likely just hand it over to you. Let's just say we have 100 million users. From that, we can start to build a picture. We also need to know what they're going to do in a day, right? We want to know what is going to be hitting our services. So, we can kind of go with our gut feel here. We're going to say, oh, an average user is going to post up 5 messages a day. They're going to follow one of their friends. And they're going to doom scroll a little bit and have 20 views per user per day. Sure. So we can start to get into some rough maths. If we have 100 million daily active users and we have 5 messages a day, that's 500 million messages a day, or about 6,000 requests a second. If our users are following one other user a day, 100 million follows a day, 1,200 requests a second. Those are both write ones. Those are both write throughputs. That's how many write requests we're going to need to handle. Look, it's kind of around the mid-range. The last one is reads. We're going to have to do 2 billion reads a day. 20 users requesting their feed every day. Per user per day. So 24,000 read requests a second. It's getting up there. We'll make a note of that, and we'll come back to that later. That's going to help guide our design. We also need to take stock of availability. So availability is our system's ability to fulfill a functional requirement. It needs to succeed within a certain span of time. Why is that important? If users on our app try to send a message and they keep getting errors, or it takes 30 seconds every time you post a message to get a confirmation, it's going to be a pretty crummy experience. Again, and I'm going to hammer this in so much, it's in collaboration with your product team. Well, with your wider team, really. We're going to say our users, most of the time, get a response within half a second when they try to send a message. It feels about right. Again, we can kind of use our gut as long as we're setting these expectations with product. We can follow when we go to click follow on another user, it succeeds most of the time within about 2 seconds. It's done less often and users will kind of just accept it. That's what we think anyway. We don't have to get it perfectly right. We can always refine these things, tune our solution after we launch, as long as we've set our expectations with product. The last one is really important for our product. We want to encourage, well, it's engagement, right? We really want users to get stuck in that loop of just scrolling and reviewing all of their friends' posts. So that really needs to be really quite reliable and happen pretty quickly. You don't want them waiting, or if they get an error screen, they could very well leave, right? We'll make a note of that and come back to that later. Consistency is a really interesting one as well. Consistency deals with guarantees. So what are the characteristics of our system when we write data and read data back from it? It's a whole huge topic all by itself that I'm not going to go into, but we're going to use 2 major models to categorize it for today. We have strong consistency, where all of your accesses are seen in sequence. That maybe sounds a bit babbly. The important thing is, this also means when we write data to our stores or write data to our services, as soon as we try to read it, we're going to get the latest state back. It's strongly consistent. On the other end of the scale, and I promise we'll get something for this, is eventual consistency. So with eventually consistent systems, you're going to have all these updates coming in, but when you go to read, at any time, they might have said, yeah, we've accepted this write, we've accepted this new data, but you might not get the latest data. The only guarantee this gives you is that if writes stop coming in, we'll eventually get the latest state. Let's take an ordering app, for example, Amazon or something. When we go and order a new book with a strongly consistent system, when we go to our order history, we're going to see, oh, the new book we've ordered. Cool, easy. If we have an eventually consistent backend, what we might see is we purchase a book, we go to the order history, and there's nothing there. That sounds really bad. In that case, how can eventual consistency be feasible? There's actually a lot of ways around this, but almost all of them will add complexity or otherwise impact the user flow. For example, you might just say, hey, if you've ordered in the last 15 minutes, it might not show up here. You might also just choose to show a spinner or something, rather than show a stale state to put the customer at ease. Either way, you're adding complexity to the application. And I did promise we'll get something in return. With strong consistency, we get these nice, consistent views. It's very easy to use, easy to debug, easy to reason about, easy to write. It's very nice. One thing we can do with eventually consistent systems is really scale out our writes. With a lot of these strongly consistent stores, it's difficult to scale these writes horizontally. We can't really have a cluster of write nodes. That's not how it works. Instead, let's say we have our big SQL Server database. All we can really do is scale it up and up and up. You're going to hit limits there in what you can actually provide, and it's going to be awfully expensive. With eventually consistent systems, we're basically accepting, hey, I don't mind if this system returns a stale result. I'd rather be more available. This also means we get there's a lot of techniques that now become available to us to improve write throughput. A lot of those hinge on things like asynchronous replication, making sure that a log of our transactions can be sensibly replicated to all of the other nodes in our cluster which are handling a little slice of our write throughput. So that's consistency. Well, I should come back a little bit on that when we go and talk a little bit more about databases. So how does it actually matter for our application? Is it okay if a user's feed doesn't show a message that they've just posted? Potentially. It's not nice, but we know we want to handle quite a bit of throughput here. And for interest's sake, we're going to say, yeah, we want to make that eventually consistent. We'll accept a bit of complexity in our application. With follows, it's a bit more hazy. If you follow another user, do you necessarily expect to see all their messages in your feed right away? I think that's a bit more of a gray area. You could argue that, hey, if I'm interested in what this person has to say, I want to get their messages right now. But there could also be a case made that we want to have that extra performance, and we don't mind if it takes a little while for those friends' messages to show up. With viewing our feed, I'd argue it's much the other way. We can accept if one of your friends posts a new message, you're not going to see it right away. It could be 5-10 seconds, it could be a minute. Again, one of those things you really want to drive with product. As long as your expectations are aligned, I think we're in a good place. So let's discuss that with our friend, our interviewer. Is it okay if the feed's sometimes out of date? Sure thing. Our interviewer is very nice. She just says yes to whatever we say. The last one here, a little bit more routine. Where is all this data? Where is all this user data going to go? If we've got terabytes and terabytes and terabytes, we need to store it somewhere. We don't want to go and run out of disk space in our database halfway through or run out on some other store. Another one that we're not going to go too much into is the durability of your data. Don't always assume you need to store all of your data. There's actually many cases where you're going to receive user data and you're either going to store it temporarily or you're going to store it somewhere transient. You don't care if that machine crashes and that data goes away. It's nice to have. So similar to what we did for throughput, let's do a little bit of napkin math to see how much data we need to store. We're going to put up a little bit of a simple schema here. I hope it's not too controversial. Just a unique identifier for the message. When it was created, we'll generate that server side. A message and a little bit of metadata around it. The metadata gives us a bit of flexibility. Maybe we'll want to stuff something in there later. That's not the point. The point is we've got about 250 bytes of data here per row. We already know. We've gone and asked how many users we have, how many messages we expect users to post each day. And I hope my maths is right here. That should be 125 gigs a day or 40 terabytes a year. This does matter. I use Postgres Aurora a lot in my day-to-day. That has a database limit of 128 terabytes. That means within a few years, we're going to start to have to we're going to have to start deleting data. Or we can have a look at an archiving process up front. On the other hand, be careful of other limits as well. We just ran into a problem where one of our tables is starting to exceed, it's getting really close to its limit. Postgres has a limit of 32 terabytes. Know your technology. So now that we've gone through what our app needs to support, both from a functional and non-functional sense, we're going to go with something a tiny bit more esoteric. It's the schema. How are we going to send this information around our system? We don't need to talk about it in too much detail, just enough for us to reason about the parts of our system. Remember our three use cases. We want to be able to post a message, we want to be able to follow other users, and we want to be able to view other users' feeds. You can see this is missing a whole bunch of stuff, but we've got the key points here. You want to post a message, you include your message. You want to follow a user, you include the user ID. You want to view the feed, you're going to just send a request and you're hopefully going to get back a big list of messages. The last part ties it all together, but I think it's actually probably the least juicy part. So if we go back to the very standard looking stack we had before, how are we actually going to talk to our services from our client? I think what I've seen a lot is people are going to generally default to REST. And that's what I really want to hammer down on or push back on. We don't want to be in the habit of defaulting to certain technologies. And it's our instinct because we develop expertise with these specific technologies. Same with our database. A lot of the time it's okay, but I'd like us to be a bit more intentional about how we design these. Instead of saying, we'll just use SQL Server because we have that there, and I know how to use it. A quick overview of some of the other things out there that aren't REST. I'm not going to go too much into REST. I think most of us are pretty aware of how to use it. We use it a lot in our day-to-day. It's mature, it's battle-tested. It caches really nicely too. But what about the other stuff? Should we hop straight to GraphQL? GraphQL is really cool, right? We can do a declarative query. Instead of being beholden to different endpoints, we can say, hey, I just want this data. I want to get these messages and from these users. It's really nice for the front-end teams. Also cuts down a bit on how much data we need to fetch. With your REST endpoints, you generally get the whole resource back. With Graph, you're only going to get what you asked for. gRPC. Fancy, super fast to deserialize and serialize data because it's just going to send binary representations over the wire. Why don't we just use that instead? Well, browsers don't have very good support for it, so if you want to use it for users to send requests to your server, you're going to need a proxy in between. So adding complexity there. It is, however, very, very nice for server-to-server comms. There's trade-offs with that. But if you have massive scale, these are things that are going to save you a whole lot of money, really going to cut down on how much compute you need. I promised to talk a little about databases. Where are we going to put our data? A lot of the time, we're going to default to one of these, right? We're going to default to Postgres. I love Postgres. I love SQL Server. I love MySQL. These have a few things in common. They run off a relational model, and they're going to generally have one write node and support for read replicas. And I know there's plugins which may let you do more replication and sharding around that. Generally, I think all of these are going to be strongly consistent. They just have that one writer node. If it's in a case where it can't send you up-to-date data, it's going to fail instead. The system will become unavailable, and you're going to get nothing. The benefit of this is, of course, it's much easier to design your applications. You don't have to deal with a lot of that eventual consistency, which you are going to have to deal with a lot in NoSQL databases. A lot of these will say they provide strongly consistent reads, but there's going to be a lot of asterisks around that. Once we release ourselves from that requirement to have always up-to-date information, like I said before, a lot of techniques become available to you to support more availability and more throughput. Even semantically, you're going to get more availability simply because the system will say, it's fine that I'm out of date, here's your data. So that's that big trade-off. Are you willing to accept eventual consistency if you're going to get a lot of throughput and availability out of it? There are ways you're going to get more complexity in your system, in your applications, or you're going to affect the user flow in some way. We also want to talk about data flows. So how data flows through our system. Now that we've got a bit of our schema, we can have a think about, okay, these requests are coming in. Can we do some pre-computation so that when the user goes to fetch a certain piece of data, it's already there hot in the cache or in a server somewhere? As a little bit of a flip side, you have caching. Once you've done a bit of work to compute something, maybe someone's feed or something like that, why not just save it somewhere so if they ask again for it, we can bring it back quickly. We don't want to have to do all that work of looking up who are their friends, what messages have their friends sent to build that picture every time. It's a lot of work. There's concerns around this as well. Your caching layer can fail. You don't want your application to become unavailable, so there's complexity here, again, for performance. It's a common theme, right? So I'm actually going to give you something that's not particularly, it's not a perfect architecture or even a great architecture, but it's something that I can back up. It's something where if you ask me questions about it, I can at least give you some amount of explanation about why I've done things a certain way. I've cut out the static assets part. That's a bit less interesting. We've got our three main requests: posting a message, following another user, and getting a feedback of what our friends have said. So going back to talking about picking the right technology, and I'll add some caveats into this later, we've put in a GraphDB for our social graph service. We've got something optimized to help us get a list of friends for a certain user. Graph databases are pretty cool. They store relationships as a first-class thing, not the element themselves. That means when you're looking for relationships based off a certain node, it's going to be much faster than doing the same on a relational database. A lot of these are eventually consistent, but as we said before, we're going to go accept that. We've discussed that with product. It's okay. You're not going to get your friend's latest messages right away. Similar when we post a message. So we can do a bit of pre-computation here. We don't want to lose these messages. That would be bad if everyone just, you post all these messages and you want to see them later, reminisce about what you and your friends have been talking about. So we'll put a database up there somewhere. Could be Postgres, could be Mongo. They'll both work. But we're also going to send something to an asynchronous worker, a feed updater. So when we know that a message has come in, we're going to go up and update your people who are following you. We're going to inject this new message into all of those feeds. That means if we've done a good job keeping our caching layer consistent when requests come in, a lot of users, especially for the active users, you're going to get your feed right away. Our service can do a whole lot less work in generating users' feeds. So it's in considering things like that I think we get a lot of value. You can explain your decisions. You're explaining why you're using something and not something else. You're picking the right technology. There's next steps. There's things I haven't covered. So moving forwards, doing a bit better than this, you want to find ways where you can deal with less data. And that's where we kind of talked about, can we pre-compute something? Can we cache something just so we have less data that needs to be computed on the fly, sent to here and there? Picking the right tool. So really reasoning about what, I'm using this technology because this. I know it's got these cons, but that's okay. And we're all in line with product about that. I've also haven't talked about some of the more, for example, sharding. It's going to improve your write throughput, but that's kind of a whole topic in itself. There's more complexity there. How are you going to split your data up among different shards, things like that. Few edge cases as well. While our solution works well for cases where users don't have a lot of followers, because that little async worker is going to go and update people's feeds. If we have Lady Gaga come in with 30 million followers and post a message, that's going to be massive write volume. These are the kind of edge cases that you want to think about. There's a cautionary tale here as well. You don't want to be, when you're picking the right tool, you also want to think about your team's skill set. There's not much reason to adapt a technology. There's a few ways you can approach it. Either you tend to shy away from using a technology that your team doesn't know how to use, or that you think you're going to have difficulty hiring for. Another way, and this takes a lot of effort, is to drive consensus among your wider engineering team about adopting a technology because it allows us to do X, Y, Z. And I can't stress how much effort and how exhausting that can be, even in the best run organizations. You want to look at procurement as well. There's going to be a lot of people in the company who are going to be pretty unhappy if you're like, I want to grab this technology, going to grab, Cockroach here, and I like this from AWS, and I like this from Azure, and I like this from GCP. It's going to be a real headache. There's contracts here that need to be negotiated. There's money. It's a lot more work than it might appear at first thought. And there's always, you aren't going to need it. I think we have a natural tendency to want to avoid maybe future uncertainty or future risk. So we can end up over-engineering our systems. We'll put this big, eventually consistent system in place and spend a lot more time working around the complexities of that than building out our core system. So please, 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 there's a lot of, you aren't going to need it. You can apply here. Remember what your competitive advantage is and focus on that. There generally is time to scale up later, to do a bit of re-architecturing if you're doing well. So with this, we're doing a bit better. We've maybe adopted gRPC for our service-to-service comms. We know what sort of throughput we need to handle, and we have a plan in place for it. And product isn't getting any nasty surprises. We've reasoned about how our system is going to perform, how it's going to behave for customers. It's always going to be buggy. I don't think we can solve that one. That's a tale for a different day. The point is, we're not trying to completely avoid failure here. We're just trying to make sure we do our due diligence and we've reasoned about our system sensibly. So the key takeaways, just quickly, please, please, please talk to product, ask lots of questions. We need to stop this habit I still see of waiting for product to give us our requirements, or product just giving the engineering team requirements and not really expecting any questions. We can get a lot of value out of just talking. Again, design with intent. Explain why you've chosen something and why you haven't chosen something. Design often. You're going to do this a lot at your workplace. If you get into this good habit, you're going to get you're going to build a lot of experience. And system design is something that does take a lot of experience, but if you get in the habit of thinking about it the right way, it's really going to improve your ability to reason, design. Makes sense, right? Practice. On the side, there's so much great information about there, white papers, tech blogs, videos. Go and do your study. Look at how Twitter's built. There's lots of stuff out there, Instagram, Netflix. There's so much free material out there. You can kind of run through why they did it a certain way, and then take a step back and try to design it yourself. Cool. Thank you very much.
Thank you very much, Nick. That was a great talk. So to get a job at Google, I don't follow the recipe. I just follow that recipe and innovate.
Yes, something like that. So,
Very good.
At the interview itself, you just want to follow in a structured way, and this was actually something that we really agreed was a really nice structured way of doing it. Non-functional requirements, functional requirements, like how much traffic your servers are going to need to handle, schema, stuff like that. You just want to be able to explain these things, and it's so important when you're talking to stakeholders or senior engineering leadership as well.
So I can use that throughout my working life, really.
Absolutely, absolutely.
Perfect. Okay, so I'm going to open up the floor for a Q&A session. Does anyone have a question for Nick? Okay, this man over here, please.
Hi, Nick.
Hey.
Working? Yeah. Well, thanks for excellent talk. So you mentioned, always reason about why you choose one tech over the other.
Mm-hmm.
And it's built on the assumption that you know all the tech and you pretty much, you know what's out there, you know alternatives, you know pros and cons. What's like the best behavior if you deal with some systems that you don't know much about? Like, I don't know, someone told you to design time series
Mm-hmm.
heavy application and you don't have a previous experience. So how would you operate in these kind of situations?
Yeah, that's a really good question. If someone approached me and said, hey, I'd like to build this with a time series database, I'd basically say, why? The first thing you want to ask is, what are we trying to solve? What is the problem that needs a time series database? For example, if it's something like, obviously time-based, right? Like a lot of your observability metrics, something like that, then sure. It's not something, I'd probably discourage people from trying to deep dive into everything. That's not something you can do. Instead, you want to have awareness of the different classes of database. So you've got your, Y column stores like Cassandra, or your time series database like you mentioned, graph database and so on. As long as you have an awareness of it, then you can go back and say, hey, okay, after our discussion, it looks like the time series database is the right way to go. I don't have much experience on this. I'm going to have to do a bit of a deep dive on it. And I think that's a plenty reasonable path forwards. Does that kind of answer the question?
Yeah, thank you. And if you're in an interview, for example, and they ask you to design something that you haven't built before,
Mm-hmm.
is it good idea to speculate or articulate or say that you don't know much about it or make a best guess, or what would be that kind of scenario?
I think there's in the interview, so what can happen is if you throw out technology you aren't very confident about, it can really fall apart. And that's why I stress it's so important to learn about the underlying concepts of how these things work instead, rather than saying, I need to know Mongo, I need to know SQL. You want to learn about how SQL databases operate, right? So at the lowest level, they've got these logs that they need to make durable, and from that they'll kind of project some data out of it. With eventually consistent systems, you've got distributed rights, and there's some work there around gaining consensus around what data's there, that kind of stuff. So my best advice is to really focus on the concepts that power these technologies. Don't focus on the technologies themselves too much. If you do this well, you can actually look at what benefits a new product proposes and say, I reckon they did it this way. And if you're getting that right often, and if you're able to say, I reckon Cockroach does things this way. They say they've got these secret sauce, but I reckon it's something like this. If you can start looking at that level, you're really on the right track, I think.
Thank you.
Thank you.
Got another question?
Yes, T.
Cool. Thank you, Nick. Great talk. You mentioned a tip if you have how you go about start that discussion with products. How do you actually drive that? I think that was a great takeaway for me. Yeah, thank you.
Yeah, so that's a good question. It depends on your organization a lot. If it's a very hierarchical one and you're just getting tickets over the fence, it's a lot of work to go and breach that gap. But I think generally, you just act in good faith. For example, if you go to a product person, to someone who's a real decision maker, and you say, hey, here's what I've been asked to build. I'd like to know what the problems we're trying to solve are and really get some consensus on what we're trying to deliver. I think most people will be very open to that. I think a lot of non-engineering people would take to that really kindly. I hope that answers your question.
Yeah, thank you.
Okay. Is that the last question? Any more? Okay, well, I've got some good news. Morning tea is served in the foyer, but a big thank you to Nick.